Hello everyone. I'd like to welcome all of you for another video tutorial session for the drug designing laboratory. So this is session number 4, in which I am going to demonstrate you how to perform protein ligand flexible docking using AutoDock with the help of AutoDock tools. So as we discussed in the previous session, we have mainly two types of docking. One is called as rigid docking, another one is the flexible docking. The main difference between the rigid docking and flexible docking is that in case of rigid docking, we treat the entire protein molecule as rigid and we give flexibility for the ligand molecule. But in case of flexible docking, we can give flexibility for both protein molecule as well as the ligand molecule. So even if we can give the flexibility for protein molecule, we are not going to give flexibility for the entire protein molecule. So we are going to give flexibility only for certain amino acids which are present within the binding site. These are the software I hope you already installed for session 3 for the rigid docking. So for performing this demonstration, so we need AutoDock tools, we need AutoDock 4, we need AutoGrid 4. We need PyMol for visualizing the final docked complex. So the same input files I am going to use for this demonstration. So the protein which I am going to use for this demonstration is hsg1.pdb and the ligand molecule is ind.pdb. So the main difference between the previous session, the rigid docking, and this is in this case we are going to give flexibility for some amino acids which are present within the binding site, the crucial active site amino acids. Okay. So the steps, if you look at the steps, it's going to be almost same for the rigid docking as well as the flexible docking, except this step, the third step. So in case of rigid docking, so we prepare the protein molecule entirely as a rigid component, but for flexible docking, so we have to define which amino acids should be treated as flexible during the molecular docking simulation and which amino acids should be treated as rigid component. Okay, so this is the only step that is different between the rigid docking and the flexible docking. So apart from that, all other steps are same. The first step is processing a PDB file, and the second step is preparing a ligand molecule. Third step is preparing macromolecule. So we have to prepare the macromolecule as a two component. One is the flexible component, another one is the rigid component. So the active site key amino acids are treated as flexible component. All other amino acids in the protein molecules are treated as rigid component. Then setting the search space, preparing the AutoGrid parameter file, starting AutoGrid 4, preparing AutoDock 4 parameter file, and starting AutoDock 4. So all of the steps are common for both rigid docking as well as the flexible docking. So okay, so first we have to pre-process, right? So we'll do that. So here I have the required files in the flexible docking folder. So these are the files which are needed for performing this exercise. So we need ad4.1_bound.dat, AutoDock 4 program, AutoGrid 4 program, hsg1.pdb, ind.pdb. hsg1.pdb is the protein molecule, ind.pdb is the ligand molecule. So we are going to dock this ind.pdb ligand molecule on the binding site of hsg1.pdb. So we are going to give flexibility for some of the amino acids which are present in this hsg1.pdb. So I have already opened AutoDock tools. So I am going to pre-process the file. So go to file option, read molecule. So I go to desktop, where I have the files on the flexible docking folder. So hsg1.pdb is the protein molecule. I am going to process it, kind of pre-processing. So as we discussed earlier, pre-processing is that if any error is present within the molecule, we have to rectify it before taking it further for the molecular docking studies. So basically what we do here is that we have to remove the water molecules, we have to add hydrogen atom. If any ligand molecule is within the binding pocket, we have to remove that. As I am using the same protein molecule, I gave no clear instruction in session 3 for the rigid docking. Just follow that, right? So I am going to remove the water molecule. So go to edit, delete, go to edit, delete water. So now the water molecule is deleted from the display. So now go to edit, hydrogens, add. So we are going to add the hydrogen. So it will pop up a window like this. This is a procedure, same thing what we did for the rigid docking. So I'm going to add all the hydrogen. Just give OK. So all the hydrogens are added, right? So you can see some white color sticks. Those are the newly added hydrogen atoms. So now we removed the water molecule. We added the hydrogen atoms. We do not have any ligand molecule bound on the binding pocket. Okay, so binding pocket is free. So there is nothing to remove from the binding pocket. It is already free. So I'm going to save this file as a file. Save, write PDB. So here I had to give the location where I had to save. So I'm going to save in the same location with the same file name. So I'm going to desktop, flexible docking. So where I'm going to overwrite this HSG1, save. So it's giving some warning message that do you want to replace it? Yes, I just wanted to replace this. Okay. So this is how to process a PDB file, right? So once we process the PDB file, so we can delete this molecule from the display, go to edit, delete all molecules. So again it pop up a window like this. So give continue, and the molecule is now deleted from the display, right? So this is how to do the processing of PDB file. So the next step is the ligand preparation. So let me show how to prepare the ligand molecule. So basically what we do in the ligand preparation is like we have to convert the PDB file into PDB-QT file. Like we had to add the charge and type of atom, and we have to define which bonds are rotatable bonds, how many number of torsional degrees of freedom. That's what we are going to do. So as I explained this clearly in the previous session, I just wanted to go a little, Okay, so the next step is we have to prepare the ligand molecule for AutoDock. So let's do that. So go to ligand option, input, open. So we have to open the ligand molecule in its PDB file format. So I have kept the PDB file in flexible docking folder in desktop. So here by default it is PDB-QT, and we have to change this to PDB file format and open this ind.pdb, that is a ligand molecule. So I have opened ind.pdb here. So now the molecule is displayed here. So with some warning message, right? So we have to accept this warning, just accept this. So this is a ligand molecule, and the next step is go to ligand, torsion tree, direct route, the same thing what we did for the rigid docking. So now this is the root point, okay, the most rigid part of the structure, and with respect to this point, the other bonds will undergo some kind of conformational change during the molecular docking simulation. So next step is go to ligand molecule, torsion tree, choose torsion. So it will pop up a window like this. So here you can see that the green color, they are the rotatable bonds, the magenta color, they are the non-rotatable bonds, and red color, they are the unrotatable bonds. So there are totally 32 bonds in this small molecule IND, and 14 bonds are as of now it is rotatable. So I'm not going to make any change. If you want, you can change. I'm not going to make any change. I'm going to accept this. Just give that. So now go to ligand molecule, torsion tree, set number of torsion. We can reduce this slightly. So as of now, the total number of rotatable bond is 14, right? So it may take, it may be computationally expensive, and it may take more time. Just for the demonstration purpose, to reduce the time, I am going to reduce this number from 14 to 6. It is not necessary that we have to change this value, always. But if you reduce the number, the time taken for the docking process will be, we can reduce the time taken for the docking process. Just give dismiss, and now go to ligand, output. Okay, save as PDB-QT. The same steps what we followed for the rigid docking. So I'm going to save this file to the same folder. So go to desktop. I have all the files on flexible docking folder. So in which I am going to save this as ind.pdb-qt. I am not going to change the file name, right? So just save. So what I do, I have saved this file as pdb-qt. So which means that I have prepared this ligand molecule for AutoDock. So let me delete this molecule from the display. Go to edit, delete all molecules. and it will pop up a window like this. Just give continue. Okay, I have deleted the molecule from the display, right? So the next step is preparing a macromolecule. So we can say that this is the step that differs from the rigid docking. Okay, so this step is completely different for flexible docking. So you have to carefully watch this part, because the only difference between the rigid docking and the flexible docking. So in case of rigid docking, so we consider the entire protein molecule as rigid. But here we are going to give flexibility for certain amino acids which are present within the binding site. Flexible residues. Go to okay. So before that, go to grid. Open macromolecule. Open. So open the protein molecule in the PDB file format. So here you have to change the file format. So hsg1.pdb is the pre-processed protein molecule. So I am just opening this file. So it will give some warning message for you. Yeah, here you can see the warning message, right? So just accept this. So this is a protein molecule which we have pre-processed. Now this software is now forcing you to save this file as PDB Qt file format. You cannot find any other option. So we have to save this file as a PDB Qt file. We are adding the charge and the type of atom to this. So I am saving it to the flexible docking folder, because I have all the files in that folder. So I am going to save this as hsg1.pdbqt. Just save this file. So after saving this file, now go to flexible residues. Okay, so choose the macromolecule. So the macromolecule is hsg1. Just I am choosing this. Okay, just accept that. So now go to select from string. So we have to first select the amino acids for which we have to give the flexibility. So we have to choose the flexible amino acids. So whatever amino acid is chosen here, so they can undergo some kind of conformational change during the molecular docking simulation. So for this specific protein molecule, the active site amino acid is arginine 8. So this protein is actually a homodimer. So it consists of two chains, A chain and B chain. So both A chain, since it is a homodimer, both A chain and B chain, they have the arginine at position number 8, and it was reported that that amino acid is very crucial for the hydrolysis of the peptide bond. So here we are going to choose that specific amino acid, arginine 8. Okay, so this will select the amino acid arginine 8 in both A chain as well as the B chain. Just click this add button. So now here you can see that something which is highlighted on yellow color. I hope that is visible. So the yellow color. Okay, so just I give dismiss. So we made the selection. So here you can see two amino acids, arginine 8 selected. So one is from the A chain, another one is from the B chain. So what we are going to do is that we are going to define to the algorithm that these two amino acids are the flexible amino acids which can undergo conformational change during the molecular docking simulation. So for doing that, go to flexible residues, choose torsion in currently selected residues. So that will isolate that specific amino acid. Just accept this by clicking close. Then go to flexible residue. Go to select from string. So we have to remove the selection now by clicking this remove. Okay, so now we have the two amino acids, arginine 8, one from A chain, another one is from the B chain. So we are going to give flexibility for this two amino acids, arginine 8 of A chain and B chain. So now go to flexible residues, go to output, save flexible PDB-QT. So here you have to save this file as flexible PDB-QT. So I am going for the flexible docking folder. So I am going to give file name for this. Just I am giving flexi flexible.pdb-qt. Just save this. Okay, so now what we did is we saved this arginine 8 of A chain and B chain as a flexible residue in a separate file. Now go to flexible residue, redisplay molecule. So it display the entire protein molecule. And now go to flexible residue, output, save rigid PDB-QT. So now the entire protein molecule we are going to save it as a rigid PDB-QT. So I'm going to save this as same folder, desktop, flexible docking, and file name is, I'm giving rigid.pdb qt. So you can give any file name, but you have to give with the file extension pdbqt. Just save this file. Okay, so this is how to prepare the macromolecule for rigid docking. So what we did is we saved 2 amino acids, arginine 8 of A chain and B chain, as a flexible residue, and the other part of the amino acids, other part of the protein molecules, we have saved as a rigid .pdbqt. Okay. Okay, so the next step is we have to set the search space, and before setting the search space, so we'll delete this molecule from the display. So go to edit, delete all molecules. So it will pop up a window like this, and you have to give continue for deleting the molecule from the display, right? So using this search space, we are going to confine that where the binding site of the protein is present. So we are going to do the same step what we have done for the rigid docking. So I'm going for grid, macromolecule, open. So we have to open the macromolecule. We have to open, so we have the macromolecule saved in 2 files. One is the rigid.pdbqt, another one is the flexible.pdbqt. For setting the search space, we have to use this rigid.pdbqt. So I open that file, and here we just give no. So the molecule is now open. So we are going to set the grid box. So for setting up the grid box, go to grid box. So for this specific protein molecule, as per the manual, okay, the dimension of the grid box is 60, 60, 60, and the position is 2.5, 6.5, and minus 7.5 in XYZ direction. So I have set up the same thing here. So now we assume that the grid box is exactly centered on the binding site. Okay, so this is the binding site of this protein molecule. So the next step is go to file, close saving current, and once if you save this, then go to grid, set map type, open ligand. So we have to open the prepared ligand molecule in its PDBQT format. So I have kept that molecule in flexible docking folder. So I'm going to open that ind.pdbqt, just give open. So now the molecule is displayed here. You can see the green color, right? So that is the newly opened ligand molecule. So the next step is go to grid, output, save GPF. So we are going to save this as grid.gpf. Okay, so I'm going to save the file to the same folder where we have all other files. So go to the flexible docking. So where I'm going to save this file as grid.gpf, grid parameter file. So just save this. Okay, so this is how to set the search space. Also how to create the AutoGrid parameter file, right? So now we are ready for running this AutoGrid parameter file. So grid parameter file. So before running this, I'm going to delete this molecule from the display. Go to edit, delete all molecules. So it will pop up a window like this. Just give continue. Right. So we deleted the molecule. Now we are going to run that grid parameter file for calculation. We're going to run with the help of AutoGrid 4, which is in the backend. So go to run AutoGrid. So we can run the AutoGrid, you will get some pop-up window like this. So we can run the AutoGrid either using this graphical interface, or we can run it using the command line. Okay. So in most of the cases you'll be getting some error if you run using this graphical user interface. So I'm not going to use this graphical user interface for running the calculation of AutoGrid. So I just wanted to do with the help of command line. So I'm going to open command prompt by giving cmd. So open command prompt here. Okay. So first I have to access to the folder where I have all the files, where I have the grid parameter file and other files. So in my case, I kept all the files on desktop. So I locate desktop. So in the desktop, I have a folder called as flexible docking. So I locate for that folder. So I'm going to display the content of this folder. So we have all the files that we have generated. So this is the file which we have generated in the last step, grid.gpf, grid parameter file. So we're going to run this grid.dpf for calculation with the help of AutoGrid 4. So if you remember the previous session for rigid docking, I have told that this is a command for executing AutoGrid 4 using the command line. So I copy paste the command here. Okay, just I'm going to execute this. So let me tell what is this command. So AutoGrid 4 is the program AutoGrid 4 name, program name -p. What is the name of the grid parameter file? In our case, it is grid.gpf -l. Grid.glg is the output file. After running this, we'll get grid.glg, grid log file, which will contain all the calculations for this. So I'm going to execute this. So the cursor is blinking, which means the program is running, and we have to wait till the cursor terminate and go to the next line. So it may take a minute or less than a minute for running this AutoGrid 4. We have to wait. Okay, so here the cursor terminated and the C: user Karthi Shanmugam displayed, which means that the program it ran successfully. So we have to check the output file from this. So let me open the GLG file. So I'm going for desktop and flexible docking, and I'd look for grid.glg is the output file after running this grid parameter file with the help of AutoGrid 4. So I'm going to open this using Notepad++ just to show you whether the process is successful or not. So let me show this. So I have to go to the end of the file, so where I can see that the AutoGrid 4 successful completion, which means that the process is successfully completed. It took less than a minute, 31 seconds for on my computer. So we got the grid log file. Okay, so we are ready for preparing the docking parameter file, and let me show how to prepare the docking parameter file. So for preparing the docking parameter file, so this is a protocol. So the same thing, almost a slight difference between rigid docking and flexible docking. So in case of flexible docking, we define only the rigid file name. For rigid docking, we define only the rigid file name. But since this is a flexible docking, we have to define which file is having the information about rigid amino acids and which file contains the information about the flexible amino acids. So go to Macromolecule, set rigid file name. So I'm going to show the path for the rigid file name. So if you remember that we have saved that file inside flexible docking folder, so in which we have rigid.pdbqt. That is a file name for the amino acids which are considered as rigid. Then go to docking, Macromolecule, set flexible residue file name. So we have to show the file which contains the information details about the flexible amino acids. So we have that in flexible.pdbqt. No molecule will be displayed, right? So just we are showing the path. Then go to docking, go to ligand and open the prepared ligand molecule. So in our case, ind.pdbqt is the prepared ligand molecule. So we have to open that from the folder. So ind.pdbqt. So now display the molecule along with a pop-up window. Okay, so here we have to accept the default parameters. We are not going to make any change, right? So the ligand is open here. Then go to docking, search parameter. We will go with the genetic algorithm. So default parameters, I am going to choose the default parameters. I am expecting the algorithm to output maximum of 10 different list conformations with the lowest binding free energy. Just accept this. Then go for docking. Go for output. So I just go for the Lamarckian genetic algorithm. We also use the same for the rigid docking, if you remember. So here we have to save this docking parameter file. So I just want to save in the same folder with the name doc.dpf. Okay, doc.dpf is the docking parameter file. So I just saved this. So now I am ready for running this doc.dpf with the help of AutoDock 4. So before that, I just wanted to close this window by I wanted to remove this molecule from the display by going for edit, delete all molecules. So it pop up a window like this. So you have to give continue, right? So we delete it. So now we are going to run the AutoDock. We have to run the we have to run the grid parameter file. So we have to run the docking parameter file. So with the help of this run AutoDock, so it pop up a window like this. So this is a kind of graphical user interface for running, for accessing the backend AutoDock 4. But we are not going to use this. Again, we are going to use the command prompt for running the AutoDock 4. So let me open the command prompt. Okay, so this is a command prompt which we have used for running the AutoGrid 4. Using the same command prompt, we are running the AutoDock 4. So this is a command I am going to use for executing the AutoDock 4. The DPF file name is doc.dpf. We have the same file name, so I am going to just copy this and paste it here. So it's not pasting, just I'm going to type this AutoDock 4 space -p space doc.dpf space -l space doc.dlg space and symbol. And the command for running AutoDock 4. So this will take the doc.dpf as the input file and execute the calculations with the help of AutoDock 4 in the backend, and it's going to output the final file doc.dlg. So I'm going to enter. Okay, so the cursor is blinking, which means that the program is running, and we have to wait for another 5-10 minutes for finishing this. So depending upon your computer speed, it may take 5 to 10 minutes, and we have to wait for that. Okay, let's wait. Okay, so now the process got over. You can see here the cursor is not blinking anymore, and the next line is displayed here: C: user Cartesian mode. So which means that the process is over. So now I am going to open the folder. So I am going to show you that. Go to desktop. So where a flexible docking, and I just look for doc.dlg. Okay, this is a doc log file is the final output file from AutoDock. So I'm going to display this using Notepad++. We will see whether it is a successful completion or not. So for that, we have to go to the bottom, and we have to see this line and AutoDock 4 successful completion. So it took around 27 minutes on my computer for finishing this job. So if I look at the rank for this, so here we have the clustering histogram. So we have 10 runs. So 7 runs clustered in one cluster, and another 3 poses they cluster in another cluster. So the lowest binding energy what we got is minus 13.45 for the 9th run, and minus 12.81 for the 10th run. Okay, and these are the different runs. 9th run, the binding energy is minus 13.45, 8th run minus 13.05, first run minus 12.39, and so on, right? So we'll see the detailed analysis in some other session, and this is how to do flexible docking using AutoDock 4 with the help of AutoDock tools. I hope